Hello everyone, this is Karthikeyan. I'm a candidate master on Code Forces, 5-star on CodeChef, ICPC Kanpur Mathura Regionals 2020 rank 27 and global rank 251 in Google Kickstarter Round Day 2021. And today I'm going to discuss the problem Purify It, which was asked in December Cook-Off 2019. The difficulty level of the problem is easy and the prerequisites are brute force and dynamic programming. The number of submissions that this problem got in the contest were 98 in Division 2. So let's move on to the problem statement. We say that a binary string, a string containing only characters 0 and 1. So basically a string is called a binary string if it only contains characters of two types 0 or 1. And a binary string is pure if it does not contain either of the strings 0 1 0 1 or 1 0 1 0 as a subsequence. Okay, so a binary string would be pure if it does not contain the subsequence 0 1 0 1 or 1 0 1 0. Now, recall that a string T is a subsequence of a string S if we can delete some of the letters of S, possibly none, such that the resulting string will become T. So, basically, a string T is a subsequence of a string S if we pick up some letters from the string S and we don't change their order. For example, there is A1, A2, A3, A4, A5. We pick up randomly some letters and for example A1, A4 and yeah, it is a subsequence. A1 and A4 is a subsequence even though it is not consecutive. But yes, the elements of a subsequence need not be consecutive, but they need to be in order as they were in the original string. So you are given a binary string S with length n. We want to make this string pure. A string is pure if it does not have the subsequence 0 1 0 1 or 1 0 1 0. And we want to make this string pure by deleting some, possibly 0 characters from it. What is the minimum number of characters we have to delete? So we basically have to make the given binary string pure, and a binary string is pure if it does not contain these two strings are the subsequence. And we have to determine that what is the minimum number of characters we have to delete in order to make the binary string pure. So let's work on it. The first line of the input contains a single integer t denoting the number of test cases, and the first and only line of each test case contains a single string s with length n. Okay, for each test case, print a single line containing one integer denoting the minimum number of characters we have to delete from s in order to make the string or the binary string pure. So let's work on it, and I would give you a few observations. So let's assume that a string is something like this. We are having some zeros, then we are having some ones, then we are having some zeros, and then we are having some ones. So let's check whether the subsequence 0 1 0 1 is present in this particular string or not, or the subsequence 1 0 1 0 is present or not. So yeah, I take this 0, I take this particular 1, I take this particular 0, and I take this particular 1. Yes, the subsequence 0 1 and 0 1 is present in this string. Now let's look for the subsequence 1 0 1 0. I take this 1, I take this 0, I take this 1. Now I don't have any other 0 to complete this particular subsequence. I don't have this particular element. So this particular string is present as a subsequence, but this is not. So this particular string is impure. Even if one of them is present as a subsequence, then the string is impure. Okay, so let's work on a few more impure strings and pure strings. Let's determine how can we say that whether a string is pure or impure. So let's work on this particular string. Let's check whether this particular string, in this particular string S, whether this particular string S1 or this particular string S2 is present as a subsequence or not. For this 0, pick this particular one. For this one, pick this one. Again a 0, pick this 0. Is there a 1? No, we don't have a 1. So S1 does not occur in this. Now, here is a 1. Pick this one. A 0, pick this 0. A 1, we don't have a 1. So yes, this particular string is pure. And in this particular string, there were 3 segments. The first segment of zeros, second segment of ones, the third segment of zeros. Let's take another string. 1 1 1 1, any number of ones. Then there are zeros, then there are ones again. So let's check whether in this string S 0 1 0 1 or 1010 is present or not. So first of all, let's check for 0101. This 0, this one. We want another 0. It's not there. This 0, this one, another 0 is not there. So this is not present. Let's check for this. We are having a 1. Take this one. We want a 0. Take this 0. We want a 1. Take this 1. But we don't have a 0. Yeah, we have form till here, but we cannot have this element. So this particular is also not present. So this particular string is also pure. So we can see that any string S which is having exactly 3 segments. Okay, first a segment of 1, then a segment of 0, then again a segment of 1 is pure. And any string S which is having a segment of 0, then a segment of 1, then a segment of 0 is also pure. Okay, so we can say that a string consisting of 3 segments, first a segment of 0, then a segment of 1s, then a segment of 0s, or a string containing of 3 segments, first a segment of 1, then a segment of 0s, then again a segment of 1. So both these strings are assumed to be pure or are pure, as I have shown you in the example. So any string, if these two strings are pure and we delete some characters from this string, let's assume that we delete a segment of 0 from the first string, then this particular string would also be pure. Okay, if we delete the last segment of zeros from the given string, then this particular segment would also be pure. This particular string would also be pure. So we can also say that any particular string having exactly 2 segments, first a segment of 1, then a segment of 0, or first a segment of 0, then a segment of 1 is also pure. Now, if from this string we delete this particular segment of zeros, what would be remaining? Only ones. So this is also pure. And if we delete this segment of ones, what would be remaining? Only zeros. So this is also pure. So we can, for sure, we can say that any string which is having exactly 3 alternating segments, first a segment of 0, then a segment of 1, then a segment of 0, first a segment of 1s, then a segment of zeros, then a segment of 1s, or exactly 2 alternating segments, first a segment of 0, then a segment of 1, first a segment of 1, then a segment of 0, or exactly one segment, first a segment of 1 and a segment of 0. If the string is of either of these 6 forms, then the string is considered to be pure. Else not. I will prove it. Why I say like this? Elsewise, if the string is of any other pattern other than these 6 patterns, then the string won't be pure. How I say that? Let's look. So let's assume that our string is having 4 segments. These are the 2 possible ways. This is the first way our string can have 4 segments. This is the second way our string can have 4 segments. Now our string is having 4 segments. Let's check whether the first string has this or not. Take this 0, take this 1, take this 0, take this 1. Yes, 0101 is occurring as a subsequence. So this particular string is impure. Now for this particular string, let's check whether it has this or not, this particular subsequence. 1, 0, 1, 0. Okay, this is also impure because 1010 is occurring as a subsequence. And if we add any segment to either of the string, this string S1 or SX or this string SY, we add a segment of 1s after this, or a segment of 0s before it, or a segment of 1s before it, or a segment of 0s after it, it would definitely be impure, because adding further segments to an impure string won't make it pure, it would remain impure. So we can say that a string which is having less than or equal to 3 segments is considered to be pure, and greater than 3 segments is considered to be impure. So we only want to determine the minimum number of characters to convert our impure string into pure string. So we want our impure string which is having x segments to have y segments, where x, if x is greater than 3, then it is impure. We want to make this particular x to y, where y is less than or equal to 3. So let's see how we would solve it. Now there are n characters in a given string: a1, a2, a3, a4, a5, a6, and so on till a7, or till an. We can also say till an. Why only till a7? So if we fix our segment L to R, and I say that this particular segment contains only zeros, I say that this particular segment is starting at L. Just 1 minute. Yeah, this particular segment starting at L and ending at R contains zeros. Then for this particular string to be pure, if we are assuming that L to R, we are only taking the zeros from L to R, deleting the ones from L to R, delete ones. Then from R plus 1 to N, we are only taking the ones and deleting the zeros, because here is a 0, then it has to be a 1. And from 1 to L minus 1, we are only taking the ones and deleting the zeros. This might be a possible combination. Another possible combination is this. From L to R, we are only taking the ones and deleting the zeros. From R plus 1 to N, we are only taking the zeros and deleting the ones. And from 1 to L minus 1, we are only taking the zeros and deleting the ones. Okay, so if we just iterate over all the possible combinations of L and R and assume both of these cases, case 1 and case 2, and determine that what could be the minimum possible answer, then we would get our answer. Okay, so let's see. So if from this L to R, if L is equal to 1, then this particular segment won't exist. 1 to 0, it would be 1 to L minus 1, 1 to 0, it won't exist because L is greater than R. Okay, then we would be having exactly 2 segments. That is also a pure string. Now, if R is equal to N, then the right segment would be equal to N plus 1 comma N. Here, L is greater than R. We won't be having a right segment. In this case, it would have exactly 2 segments. Again, the string would be pure. Now, if L is equal to 1 and R is equal to N, then we would be having a single segment 1 comma N. And if we are assuming our string to have a single segment, then it is also pure. Okay, so what we are trying to do here, we would just fix our segment from L to R, count the number of zeros in it, fix our segment from R plus 1 to N, count the number of ones in it, fix our segment from 1 to L minus 1, count the number of ones in it, delete the number of zeros from here, delete the number of ones from here, and delete the number of zeros from here. So what would be our resultant string? It would be some ones, some zeros, and some ones. So yes, this particular string, it is a pure string because it would have less than or equal to 3 segments. So yes, this would be a possible answer. And what would be the number of operations to get this string? The number of zeros from 1 to L minus 1, the number of ones from L to R, and the number of zeros from R plus 1 to N. And in the same way, L to R, R plus 1 to N, and 1 to L minus 1. If we have a 1 here, 0 here, zeros here, we would delete the ones from this segment, zeros from this segment, and 1 from this segment. So this particular string, what would be the string form? Only zeros would come from this segment. Only ones would remain. Only zeros would remain. What would be the number of operations required to obtain this particular string? The number of ones in R plus 1 to N, number of zeros from L to R, and the number of ones from 1 to L minus 1. So this would give us the number of operations to obtain this particular string. And just fixing the L to R and iterating over these 2 possible combinations, 0 segment, 1 segment, and 0 segment, or 1 segments, 0 segment, and 1 segment. Segment of 1, segment of zeros, and segment of ones, or segment of zeros, segment of ones, and segment of zeros. And taking the minimum of all the possible combinations would give us our answer. So let's work on a few test cases. The first test case is 0, 1, 0, 1, 1, 0, 1, 0. Then there are 1, 2, 3, and 4 ones. Then there are 0, 1. So 0, 1, 0, 4 ones, and a 0, 1. Okay. So it's a 0, 1, 0, 4 ones, and a 0, 1. So here we would just, so I would just give you a simple demonstration. Let's assume that we fix from here to here, L to R. Assume we only take zeros from here. We have to delete the ones from here. We take ones from here and we take ones from here. We have to delete the zeros from here. No zeros. We have to delete the zeros from here. 1, 0, 1, 0, 4 ones, and no zeros. So this is the number of operations, and the required string would be 1 from here, zeros from here, and 1 from here. This might not be the optimal answer, but I'm just showing you how to do it. So now let's move on to the code. Here is my code. Here T denotes the number of test cases. This is the string S. I take the string S, attach a hashtag at the beginning of the string in order to make it one based indexing in the string. Be sure to do this, and basically it would help you use one based indexing, and I find one based indexing pretty easy. Then I initialize n equal to s dot size minus 1. Here you might get an error because you might initialize s dot size and assume that this is the initial size of the string, but after attaching a hashtag the size of the string increased by 1. That's why we write s dot size minus 1. Keep a note of that. We make a dp table, okay, dp of n plus 1 and 2, where dpi0 will give the number of zeros in the first I characters and dpi1 will give the number of ones in the first I characters. I memset the dp table. If you don't memset the dp table, then it would have some garbage value and you might get an error. I start the iteration from I equal to 1 till n, and dpi0 is equal to dpi minus 1 0. The number of zeros in the first I characters first is equal to the number of zeros in the first I minus 1 characters, and the number of ones in the first I characters is equal to the number of ones in the first I minus 1 characters. Now, if the ith character is a 0, then si minus 0 would correspond to a 0. If the ith character is a 1, then the si minus 0 would correspond to a 1. And I would increment dp of I si minus 0. After this, I initialize the answer equal to n, because an empty string is a purified string, and in order to make the string as empty, I would like to delete the whole string, and in order to delete the whole string, the length of the string is n. So in order to obtain an empty string, we need n operations. I iterate from I equal to 1 till n, then from j equal to I till n. I am having my segment from I to j fixed. Now these are the two formulas. Now in this particular segment, the segment from I to j, I am just counting the number of ones from I to j and the number of ones from I to j, because I am only considering the zeros from I to j. Here I am counting the number of zeros from 1 to I minus 1, or basically in the first I minus 1 characters, because I only want to consider the ones in the left segment. And here I am counting the number of zeros from j plus 1 to n, because I only want to consider the ones in the right segment. So this particular thing corresponds to this example, which is 1, 0 and a 1. And this second thing corresponds to this thing, 0, 1 and a 0. So I want the middle segment to only comprise of zeros. So what would I delete? I would delete the ones. What are the number of ones I have to delete? dp of j1, the number of ones in the first j characters, minus dp of I minus 1, 1, the number of ones in the first I minus 1 characters, which would give us the number of ones from index I to index j. Now, here in the left segment, I want only ones. What would I delete? Zeros. The number of zeros in the first I minus 1 characters. In the right segment, I want ones. What would I delete? Zeros. The number of zeros in the segment from j plus 1 to n. So dpn 0 minus dpg 0. And the same is here for the 0, 1, 0 segment. After this, I just take the answer equal to minimum of answer comma this expression, and answer equal to minimum of answer comma this expression. Be sure to take the minimum properly, and after I just print the answer in a new line for every test case. You have to print the answer for every test case in a new line. That is also a point that you have to keep in mind. And I have used this line for fast input and output. So you can see that this is an accepted solution. If you have any doubts regarding this approach, you can ask in the comment section, and thank you for watching the video.